Okay, next is plot of intensity versus wavelength. So as I told you in the previous video that for continuous X-ray, if only, let's say, only continuous X-rays were produced, the curve would have been like this. Okay. If only characteristic X-ray was produced, the curve would have been something like this. Okay. Then if we combine these two, because simultaneously both type of X-ray keeps on getting produced, so the eventually the curve comes like this. Okay. So this is K beta, K alpha, L gamma, L beta, L alpha. Now we need to find which one of these has higher energy. Okay, let's move here. Now, as we know, let's say for if it was happening in hydrogen atom, so energy of this one will be minus 13.6, minus 3.4, minus 1.51, and so on. So energy difference between which two shell is highest? If electron is moving from, let's say, here to here, then energy difference will be 10.2 electron volt. For K beta, energy difference will be 13.6 minus 1.51. Let's say that is approximately equal to 12 electron volt. So for K alpha, our energy difference is 10.2 will be SC by lambda of K alpha. So lambda of K alpha will be HC by 10.2. Similarly, wavelength of K beta will be HC by 12. So which of these two wavelengths is greater? As you can just see, wavelength of K alpha will be greater. So we can I can say wavelength of K alpha will be greater than wavelength of K beta, and similarly it will be greater than wavelength of K gamma, and so on. Now let's compare between alpha, K alpha and L alpha. Okay. Now in K alpha we have found the energy difference was 10.2 electron volt. In L alpha the energy difference is 3.4 minus 1.5, that is approximately 1.5. So for L alpha, energy difference between these two orbits is 1.5, that will be equal to Hc by lambda. This is L alpha series, so lambda of L alpha, from here we are getting lambda of L alpha is equals to Sc by 1.5. Okay. Now compare wavelength of K alpha and wavelength of L alpha. Since 1.5 is lesser than 10.2, means wavelength of L alpha will be more than wavelength of K alpha. Okay. Now let's find these in curve. See, as we can see here, wavelength of K alpha, because x-axis is wavelength, so wavelength, this will be wavelength of K alpha, and this point will be wavelength of K beta. So wavelength of K alpha is greater than wavelength of K beta. So that's what we had actually found. Similarly, wavelength of L alpha and wavelength of K alpha, which of these two is greater? As you can see, wavelength of alpha is greater than wavelength of K alpha. So like that, we can plot the curves. You have to calculate the energy difference between the orbits, and from the energy difference, you can calculate what is the wavelength of photons or X-ray which is being emitted. Okay, thank you.